How does an Irish potato suddenly sprout leaves in a dark kitchen without soil? These tubers are nature's underground storage vaults, densely packed with energy to grow new plants. This diagram illustrates the core anatomical rule that divides these crops. On the left, the sweet potato is a root tuber, which is a modified, swollen root. On the right, the Irish potato is a stem tuber, a modified stem identifiable by nodes called eyes. Locating these eyes provides the biological roadmap, acting as specific origin points for new growth. Since tubers do not grow from traditional seeds, farmers use vegetative propagation. This involves taking a healthy section of an existing plant to start a new life cycle in the field. This diagram shows the three primary planting materials used in Uganda. Cassava requires mature stem cuttings about 20 centimeters long. Sweet potatoes use vine cuttings from the top of the plant, and Irish potatoes rely on seed tubers that have already begun to sprout from their eyes. In this 3D cross-section, we see why tubers require loose soil, like mounds or ridges, to physically expand underground. For Irish potatoes, farmers must perform a maintenance step called earthing up, where they continually pile fresh soil around the base of the plant stem. Exposure to sunlight triggers a chemical reaction in Irish potatoes that produces high concentrations of solanine. This turns the skin a distinct green and makes the tuber toxic to humans. To prevent this, the farmer actively earths up the crop, covering any exposed tubers with soil to block the light and keep the developing starch safe and edible. A farmer's ability to manipulate the soil environment determines whether the final harvest provides life-saving energy or a dangerous poison. That precision must continue through the harvest. Farmers use a forked hoe to avoid bruising the tubers, as broken skin creates a gateway for bacteria that causes the crop to rot within days. Pause for a moment and look at this drawing. Based on the presence of these eyes, can you identify the type of tuber shown and name one Ugandan example? This is a stem tuber, like a yam or Irish potato. Once harvested, many tubers face the immediate threat of spoilage due to high water content, while varieties like bitter cassava contain naturally occurring cyanide. This diagram shows how a solar dryer neutralizes these threats. After the tubers are washed, peeled, and sliced, they are placed on mesh racks. Cool air enters the bottom, heats up under the plastic cover to dry the slices uniformly, and carries the moisture out through the top vents. This drying process acts as a scientific intervention, neutralizing toxins and removing the water that causes rot. It turns a perishable harvest into a stable food reserve for the dry season. Applying these principles allows Ugandan farmers to move beyond basic survival. Understanding soil and plant biology ensures a reliable food supply even when rains fail. This life cycle moves from the initial stem cutting to the protected tuber, through hygienic solar drying, and finally to the production of milled flour that is ready for storage or the market. Mastering these steps secures a steady income at local trading centers and ensures that staples like posho remain available for the family table year-round. Take a screenshot of this summary table detailing crop types, planting materials, and essential care and processing steps. Tubers are biological savings accounts. Respect their anatomy and processing rules to guarantee food security for your community.